Hello everyone, today we're going to be graphing the cosine function. So let's start off similarly to how we did when we were graphing the sine function. We're going to use the unit circle to get those y values out. So I'm just going to go ahead and quickly fill in this table using the x values or the cosine values from the unit circle. You can see after filling out the table that now we can go ahead and plot these points. Cosine of 0 is going to be 1. Cosine pi over 6 is that 0.88. Pi over 3 is 1/2. Pi over 2 is 0. 2 pi over 3, we've got negative 1/2. That negative 0.88, negative 1 at pi. 0.88 again, but the negative. Negative 1/2, 0, positive 1/2, 0.88, and then we're back at 1. This is one full cycle of the cosine function. You'll notice that it looks similar to the sine function, except for we start up the amplitude, midline, down the amplitude, midline, up the amplitude. So where the sine graph starts at 0, cosine starts up the amplitude, but we'll talk about how they're related in a minute. All right, so all of the properties that we learned about the sine graph are still true for the cosine graph. As you can see, the midline is still that middle point between the maximum and the minimum. Okay, you can see the amplitude for the parent graph of the cosine function is still 1. The distance between the maximum and the midline, or the minimum and the midline, still amplitude equals 1. The period is still 2 pi because if you notice, it takes one complete cycle of the cosine circle of the cosine function to reach 2 pi before we start repeating that pattern. The frequency is still 1 over 2 pi. The graph of cosine theta oscillates between concave down and concave up. You can see on this interval we're concave down. At this point of inflection, we turn concave up until the next point of inflection, and then we're concave down again. One thing about the sine and the cosine graph is they are what you call sinusoidal functions. And what that means is that any function that involves additive and multiplicative transformations of the sine function can be considered a sinusoidal function. We saw this yesterday when we were doing some shifts of the sine function. We were actually also graphing the cosine function, we just didn't know it yet. The sine and the cosine functions are both sinusoidal functions because in order to get the cosine function, I can just take a sine function and perform a horizontal shift of left pi over 2 or 90 degrees, and that will become the cosine function. So with a little shifting, that sine function would lap directly over this cosine function right here. All right, and back, you can see that we have some key points here. I don't really need to graph all these points, but I can graph the key ones, 1, 2, 3, 4, and 5 points along that graph. With the starting point, I have to divide the rest up into 4 sections, and that's how you can find out where these points should lay. Let's look at some examples. So we're going to use what we know from sine functions and what we know about cosine functions to go ahead and graph some of this stuff right here. I've got 2 cosine 1/2 theta. So where is that midline located? Remember that d value out on the end is the midline, and in this case there's nothing out there, so our midline is at y equals 0. To graph this, let's go ahead and draw the midline in right away. I like to do that so I know where my graph is going to be anchored. The amplitude is that a value, which is 2 in front, and the period is similar in behavior to the sine function. It's 2 pi over b, and in this case pi is 1/2, or b is 1/2. So 2 pi over 1/2 is going to be 4 pi. and the frequency is 1 over 4 pi. So it's going to take us 1 over 4 pi in order for an entire rotation to be completed. We do have 4 pi up here between negative 2 pi and 2 pi. So let's go ahead and do what we can with this function, okay? So because of the way this graph is labeled, we're going to have half of the cosine function going to the left and half of the cosine function going to the right. All right, so I have an amplitude of 2, and we start up the amplitude. So I know I'm going to start that function here at 2. We're going to hit the midline at pi now, and then we're going to go down the amplitude at 2 pi. And I can do the same in the opposite direction. Pi is the midline, and 2 pi is down the amplitude. And I really have completed one complete rotation of this cosine function, but not exactly, because of the way this is labeled. This is just half of that cosine function that would go out in this direction and half of the cosine function in this direction, but we have completed one complete period here. So if you're having a hard time wondering where you put your points, you can just look at the period 4 pi and multiply it by 1/4, because we've got 4 anchoring points that we can use, not including one of the endpoints. And that tells me that every pi I should be having a key transitional point, like the pattern we saw before. So there's that one. Let's do our next function. It says 1/2 cosine 2 theta minus 1. Now we have everything going on here. Where's the midline located? It's located at -1. The amplitude is 1/2. The period is going to be 2 pi over 2, which is pi, meaning one full rotation will be completed by pi, and the frequency is 1 over pi. Let's first things first draw in the midline at -1. Okay. And now I need one full rotation done by pi. So for the cosine, we're going to start up the amplitude, which is 1/2. We're going to come down to the midline, down the amplitude, midline, up the amplitude. And now I have completed one full rotation of that cosine function in pi units. So we can keep going with this. You might have to adjust your x-axis if it's not suiting you, but so far we've been able to make it work. Oops, I kind of got out of pattern here. All right, and there's that graph. Let's look at the next one. I've got 1 minus 2 cosine theta. So what is going on with this graph? I've got the midline located at y equals +1. I've got an amplitude of 2. I have a period of 2 pi because b is 1. The frequency is 1 over 2 pi. So one complete cycle will be done within 2 pi time. And if you notice, I do actually have -2 cosine theta plus 1. If you're having a hard time noticing that, this is a reflection over the x-axis, or the midline. So let's draw that midline in. There's 1. I've got an amplitude of 2. Cosine functions start up the amplitude, but in this case, we're doing a reflection, so it's down the amplitude, and the amplitude is 2. So we're going to start our first point on the y-axis down the amplitude. we're going to hit the midline at pi over 2, up the amplitude at pi, midline at 3 pi over 2, down the amplitude at 2 pi. And we've got one full rotation of the cosine graph there. And we can continue on this pattern and complete the graph. All right, let's look at another one. -1 plus 4 cosine 4 theta. The midline here is located at y equals -1. The amplitude is going to be 1. We have nothing changing that amplitude. The period is definitely changing here. You can see that the period, the b value is 4. So that's going to be 2 pi over 4, which is going to be pi over 2. And the frequency is going to be 2 over pi. So what this means is by pi over 2, I need to complete one full cycle of this graph. So this thing is going to be really scrunched up. Let's go ahead and draw that midline in at -1. And by pi over 2, I have to reach completion of this graph, okay? So I have really got to crunch it in here. So if you're curious about, what your intervals are going to be, pi over 2 times 1/4 is going to be pi over 8. So I'm going to zoom in. You don't have to do this detail every single time. I'm going to have 1 pi over 8, 2 pi over 8, which is going to be pi over 4, 3 pi over 8, and 4 pi over 8, which is pi over 2. Those would be my placements for my values. Let's go ahead and do this. Cosine function starts from the midline up the amplitude of 1. So we're going to be up 1. At pi over 8, we're going to hit the midline. At pi over 4, we're going to go down the amplitude. We're going to hit the midline again and go up the amplitude. And we've completed one full rotation of the cosine graph by pi over 2. This is super shrunken, right? And we can continue this pattern across if we would like. And we can even go this direction. And we can even go across in this direction. All right, and we could continue that, but we've done more than enough. All right, let's continue on to the back. We've got more functions to graph here. So on the top, we've got 1 minus cosine theta. Well, what's happening here is we've got, negative cosine theta plus 1. The midline is located at y equals 1. Let's draw that in. We've got an amplitude of 1, but notice there's a reflection. The period, nothing happened with it. It's still 2 pi. There's no b value. Frequency 1 over 2 pi. So cosine function starts up the amplitude, but this is a reflection. So we're going to start down 1 from the midline. Pi over 2, hit the midline. Pi, we're going up the amplitude. 3 pi over 2 midline, 2 pi down the amplitude because we're doing the opposite. And there's one full rotation of that cosine graph, and we can go the other direction also to get 2 full rotations if we would like. All right, let's continue on. It says find the amplitude, the frequency, horizontal shift, vertical shift, and sketch the graph. Okay, we can do that. One thing is that if you remember the standard form of a cosine or sine equation, it's d plus a cosine b theta minus c. So one thing is, in order to get that b value and the accurate shift, we need it to be outside of the parenthesis. Notice how b is inside the parenthesis here. I still know b is 2, but I need that outside of the parenthesis to get an accurate horizontal shift. So let's go ahead and rewrite this. It's going to be 3 cosine theta, I'm sorry, not theta, 3 cosine. And we're going to take the GCF out, which is 2. Theta plus 90 degrees plus 1. All right, now I can look at everything accurately. So let's talk about this. I've got the midline. Actually, it didn't ask me for the midline. I mean, it's helpful for when we're going to graph, but let's just do what it asks us in order. The amplitude it asked is going to be 3. That's our A value in front. The next thing it asked about is the frequency, and in order to get the frequency, we have to talk about the period. The period is going to be 2 pi over 2, which is pi. So the frequency is going to be 1 over pi. The horizontal shift that we see is looking like 90 degrees to the left. And the vertical shift, or the midline, is up 1. So let's go ahead and draw in that vertical shift, the up 1. And then we can try and make all this work, okay? So we need one full rotation to work by finish by pi. The amplitude is 3, and we also have a 90-degree shift. So what I'm going to do is I'm going to do everything but the 90-degree shift first. So if I had this cosine function, I would start up the amplitude on the y-axis. I need it to complete by pi, so I'm looking at pi over 4 as being my anchoring points, the distance between my anchoring points. Hit that midline. Now I'm going down 1, 2, 3, the amplitude, midline, and then up the amplitude. All right, so right there, I have the bones of this function, but I have not completed the 90-degree shift left. So now we're going to do that. Here's 0 degrees and negative 90 degrees. We're going to shift these points left. Shift the point left. Shift the point left, left, and left. All right, now the green is the final product and the answer to this question as far as graphing goes, okay? And we can continue on. So it's helpful to kind of anchor it down and then maybe do the shift after. If you can visualize the shift all at once, that's amazing. I love that for you. But for safety, you can go ahead and put some anchoring points like I did, those red ones, and then shift afterwards. Okie dokie. And we can just finish up this graph right there. So we've got an amplitude of 3, a period of pi, a horizontal shift, left 90 degrees, and up 1. All right, let's look at a next example together. You can see down here, same situation. We have the function, but it's not necessarily in standard form. Let's pull the b value out so that we can accurately see what the shift is. Right here, you can see our shift of 30 degrees. So let's answer all the questions. The amplitude is 2. The period is 2 pi over 3. The frequency is 3 over 2 pi. The horizontal shift is right 30 degrees, and the vertical shift is up 1. Let's go ahead and put in that vertical shift of up 1. And let's talk about this. All right, 2 pi over 3. This could be a little bit intimidating. Let's take it to the side. I've got 2 pi over 3 is what I need, the distance I want for one full cycle to be completed. I'm going to multiply that by 1/4 to see what each interval or where each anchoring point needs to go. And I get 2 pi over 12, which is pi over 6. So this graph that I have down here has, you know, written in stone these values. If I was graphing this on graph paper, I wouldn't use pi over 2 and pi. I wouldn't do that. So on here, I'm just going to pretend like, you know, those don't exist, and I'm going to make my own scale. I'm just going to basically like white these things out. So right here, I would have pi over 6. And then I'm going to add another pi over 6 to that. And that would be 2 pi over 6, or pi over 3. And I would add another pi over 6 to that, which would be 3 pi over 6, or pi over 2. And then I would add another pi over 6 to that, and that would be 4 pi over 6, or 2 pi over 3. And I'm just going to adjust the scale to my own liking. I'm not going to use this particular numbering here. Like I said, if I was making graph paper on my own, these are the points I would choose. Negative pi over 6, pi over 3, negative pi over 2, and negative 2 pi over 3. And the rest of it, you could keep adding if you want to, but I'm okay with it just right where it's at. Okay, so the way I have it here, I need one full rotation done by 2 pi over 3. Okay, I need amplitude of 2 and a shift up of 1. We already got that going on here. So let's do that. We start up the amplitude with the cosine function, midline, down the amplitude, midline, up the amplitude. And I just changed the scale to help myself. And I could continue on with labeling this thing by adding pi over 6 if I want to. I don't want to, but I could. So there's our graph all the way across. Okay. But one thing that you have to remember, and I didn't do yet, this isn't our final graph, is we need to do that shift 30 degrees to the right. So our final graph will be in green, and I'm going to do 30 degrees to the right. Pi over 6 is 30 degrees, so we're going to shift every point to the right 1 unit, which I have made pi over 3. Or I'm sorry, pi over 6, 30 degrees. I lost my spot. Did I mess that up? Yes, I did. Oh. Didn't go down far enough. There we go. There we go. So we just shift everything. Okay. And now you can see that our actual function, the y function, is in green. Last one we can do together, or if you want to try and do it on your own, pause the video and go ahead and do that. I'm going to do the same thing for sine 3 theta minus 30 degrees minus 2. Okay, so let's talk about everything that I have here. I've got an amplitude of 4. I've got a period of 2 pi over 3. I've got a frequency of 3 over 2 pi. I've got a horizontal shift of right 30 degrees. And I've got a vertical shift of down 2. Let's start first by putting in the midline. Negative 2 is in there. And it's the same period as above, so I'm going to do the same exact thing. I'm going to literally make this my own scale. And that's perfectly fine. If I had graph paper right here, I would not be using these scales. I'm going to just zoom into what I need it to be. And that's going to work for us. All right. Alrighty, let's go ahead and do this then. So the amplitude of 4 starts up 4, up the amplitude, so 1, 2, 3, 4. Pi over 6, I'm hitting the midline. Pi over 3, I'm going down 4, 1, 2, 3, 4, it's off the graph a little bit. Pi over 2, midline, 2 pi over 3, up the amplitude. And don't forget the 30-degree shift to the right. 30 degrees is pi over 6. I'm moving every dot to the right 1 unit. And I can connect those, and that is the actual function. Now I can continue this pattern if I would like to get even more points, but you don't have to. Your homework usually says to do 2 periods. So as long as you have that, you're good, and we definitely do. Sorry about that bottom falling off a little bit. Okay, so that is graphing cosine functions using everything we know about sine functions as well. Good luck on your homework, and we'll go over all the questions when I come back. Bye.